following examples just give more practice with logs. So we're going to just play around with log statements. You can see we're not solving exponential equations here. We're just playing with logs a little bit. It'll take us a little bit to come to the exponential equation part because we really want to get comfortable with logs first. So it says evaluate the following, and all I give you is log in a base of 125. Well, what part is missing from this log statement? I have the base, I have the argument, I'm missing the exponent, right? I'm missing the log. So that's the part I'm trying to solve for here. So what exponent, what log, I'll use the word log because I'm not going to use the word exponent because it's in log form. What log makes this statement true? 5 to what power equals 125? 3, right? So x is 3, right? So let's move out of, what's the answer to this question? 10 to some exponent equals 1, right? Does everyone remember that there was an invisible 10 here? Okay. 0, right? So this log equals 0. What about this one? Take a second, see what you can make of this one. Play around with it and see if you come up with an answer. Okay, anyone come up with an answer? Is that you, Carl? You said 1? How many people agree with Carl? I see some nods. Okay, again, we work inside out. So log, the log of 4 to the argument 64, so the exponent would be 3, correct? So then I'm looking for log in base 3, argument 3. Well, the only exponent that makes that statement true is 1. Okay. So that's great. Now let's see, now it's saying solve for x. So you're actually given an equation. Here you weren't, you were just given an expression to find the value of, right? Now you're given an equation, a left and right hand side. So you can kind of see a little bit about what you're working with here. Solve for x. Now, I don't know if any of these are exponential equations. It doesn't look like it because you're given the exponent in all the cases, right? So these aren't exponential equations. These are like a little baby log equation. I'm going to give you a few minutes. See if you can find the answer to those 4. You should be able to, with your current math skills and your current math learning, you should be able to find the answer to all of these because they're not exponential equations. Okay, what's the answer to A? What does x equal? 216, I agree. Did you have to put it in exponential form, or did you just look at it and solve? So 6 exponent 3 is x. X is 216, perfect. What about this one? What's the answer? 81. X is 81. How did you solve that one? Just by inspecting it, or did you actually have to put it into exponential form? Yeah? So this is the base. X to the power of a half equals 9. Okay? We know that x to the power of a half is another way of writing square root, right? So you could have looked at it, square root of x is 9. How many people did it a different way? Did anyone do it a different way? Remember what I showed you? Like if you ever want to get rid of a power of an exponent, you know what you could do? Just multiply by its reciprocal. Whatever you do to one side, you do to the other, right? Because a half times 2 would give you 1. That's another way to approach it. Okay, this is a tougher one, right? I would have to write the base down, then write the exponent, and that's going to give me my x. All right. So now what do? I have a negative exponent. I can't proceed with negative exponent. So how do I make a negative exponent positive? Take the reciprocal of what the base is, right? The reciprocal of the base. So that gives me 4 to the 1/3 equals x. Agreed? So I guess that's all I can say. The cube root of 4 equals x. And if I didn't ask for decimals, I'd have to leave it like that, right? Because I can't simplify that anymore. I would just leave it like that unless I asked for decimals. What about this one? X to the 5/2 equals 32. How did you get that? Did you multiply by the reciprocal? Yeah, so that's the same skill. I would probably do that here. I would multiply by the reciprocal. So I just raise that to 2/5 and then find the 2/5 of this one. That's what I would do. These guys cancel, so I'm left with a nice x. But then I still have this 32 to the 2/5. Did you then convert it to a radical, Joanne, radical form? Like, did you think of this as, okay, well, that's the 5th root of 32 squared? Or, yeah? Yeah. If I had to do it without a calculator, that's how I would think about it. So you're constantly going from back and forth, right, between exponential and radical form sometimes within these equations. So that's 2 squared is 4. How many people just played around in their head till they got the number that worked? Kind of a trial and error strategy. All right, how do you feel about the form of logs? Now you know all the parts, right? The base, the exponent, which the log equals the exponent, right? So the base, the exponent, and then the argument. Okay, I'm going to flip by all our graphs. So we did our log graphs yesterday. We'll get some more coming up. And now guess what? We have our old friend solving exponential equations with the same base that I'm going to get you to do. I'm going to get you to do for homework. This is just more repetition of that, so you can work on that. I don't think we really need to go over. I think most people are feeling kind of comfortable with the same base stuff, right? Maybe these get a little trickier down here, but I'll give you the answers. I'll post them on the blog because I want to start getting deeper into logarithms again. Now, do you remember you had the laws of exponents? They're printed in your textbook, and they're also recorded on one of the first pages of this little package. The laws of exponents. So we've got the product, quotient, power, negative exponent rule, exponent of 0, exponent of 1. So remember these, I just want you to look again at the product rule. Multiplying two bases, we add the exponents, right? Dividing the same bases, we subtract the exponents. An exponent raised to another exponent means we multiply them. I think those are the ones I really want to highlight here, because guess what? in the world of logarithms, we have laws of logarithms as well. So we're going to, I'm going to come back to example 1. But if we read the text here, it basically says the laws of logarithms, we have to use them. They are also used to simplify log expressions and exponents. So the laws of logarithms are used to simplify log expressions and equations. And we already have realized that logs are necessary in order to solve exponential equations. As with logs, there are laws we use, or as with exponents, there are laws that we use with logarithms. These are used to simplify log expressions. So here we go. There aren't as many rules, I think, as with exponents, but they're very similar. Look at this. If I have log in just any base of a, of two numbers multiplied together, I can separate those logs out as two separate logs, and the multiplication becomes an addition. That's kind of the reverse of exponential, right? If I'm multiplying two bases, I add the exponents. So multiplying a base, if the argument is a product of factors, I can separate those factors out through addition. Division separates out to subtraction, right? Just like our division of exponents. And this is a very interesting one. This is actually, in my opinion, the most powerful log rule. I'm going to actually kind of highlight this one. This is the most interesting thing about the laws of logs. Look what this one says. Log of any base of an argument raised to the exponent, that exponent can just come down and become a coefficient. Okay? Which is fascinating, right? So that means if I had something like this, example, let's say if I had log in base 4 of, I don't know, 11 to the power x, and that's usually what I'm going after, right? I'm usually going after an exponent that I don't know. That exponent can come right down as a coefficient. And this stays the same. Now that might not look that powerful now, but look what a log can do. It can take an exponent and just transform it into a coefficient. And the big problem all the time was having exponents as like variables as exponents. We don't know what to do when the variable's exponent, but when the variable's a coefficient, we got lots of rules to deal with that, right? So we're going to see that's going to be a very powerful law that we can utilize. Okay, it's also helpful to know when the argument and the base agree. If there's an exponent on the log, that's actually the log that you're looking for, right? Log in base a of a to the n equals n. Log in base a of 1 equals 0. Log in base a of a equals 1. Okay, and we can just verify those really quickly. I'll show you why they work so you don't have to memorize things. Anytime you're kind of stuck with a logarithmic equation, because to be honest, anything with the word log in it looks pretty challenging, right? It's a very high-level math skill. You're not introduced to logs till grade 12, so you've never seen them before. But the reason this is true, look at, if I put the base, this is the base, this is the exponent, this is the argument. Right? So if the argument itself has an exponent, and these two guys agree, your answer will just be whatever the exponent is, right? This one, base exponent, has to equal argument of 1. Base exponent 1 has to equal the argument, right? That's all that means. Okay. Now, once again, it says solve to 2 decimal places the following exponential equations using trial and error. I'm going to come back to this one. But this is essentially why we're studying logs, to handle 2 to what power equals 10. I don't know. I can make a guess, but I'm not sure. Same as 4 to what power equals 25. I don't know. At the top of my head, what do you think Take a guess on 2 to the x equals 10 without even picking a calculator up. What do you think the answer is going to be? Kind of ballpark it. What 2 numbers will my exponent be between? Right? X must be between 3 and 4, right? Because 2 cubed is 8. 2 to the 4 is 16. I'm looking for 10, right? So it's between 3 and 4. Is it going to be closer to 3 or closer to 4? Closer to 3, right? Because 8 is closer to 10. What is this one? X must be between what 2 numbers? 2 and 3, because, okay, well, let's check. If x was 2, it would be 4 squared equals 16. 4 cubed equals, do you have that one memorized yet? 64. Is the exponent closer to 2 or closer to 3? Way closer to 2, right? And that's about it. That's all we can do without a calculator, right? With a calculator, I can play around a bit, which is what I asked you to do for that assignment yesterday. You can play around a little bit and get a little closer, but really that's all we can do. Well, we're going to find logs will allow us, of course we still need a calculator with the logs, but allow us to hone in without having to play around, right? Okay. Now, unfortunately, we don't have our laws of logs right in front of us. Should have gotten a formula sheet for you guys. Maybe that's what I'll do over the, okay, so we'll have to do some flipping back and forth. Then I'm going to see if I can get a formula sheet printed out for you guys. Okay, it says use the laws of logs to rewrite as a single logarithm. I have log in base 4 of x, log in base 4 of y. So how could I record those together? Hang on a sec. See if I can download a formula sheet for you guys. Okay? Give me 1 minute. Formula sheet, page 42. I'm going to print one off for you guys. Okay, so let's try this one. Okay. Print. Sorry, guys. Okay, print page 59. Okay, give me 1 sec. I'm just going to go see if this prints off, and then you guys can have the formula sheet right in front of you. So we'll have to keep flipping back and forth. the whole first column is all trig stuff that we're gonna get to. So this just saves you from flipping back and forth to the, like I have them printed here, right? So you don't have to flip back and forth, but here's where all the log stuff is, right? Okay, so now let's see. Notice that these formulas work both ways, right? We use them to break apart an argument. We can, if we want to break the argument apart, we can separate them. But if you're given a log in expanded form, right? This is the expanded form. I can use the expanded form. What the laws also do, it allows me to take two logs and push them together, right? So this is expanded on this side, right? Expanded form. And this would be called, to me, it's simplified, right? Because it's smaller. I don't know. That's how I would say it. So we can compressed, right? Compressed or simplified, expanded. So here you're given expanded and you're compressing. You have to make sure, though, notice how these log rules work. If I'm taking expanded logs and compressing them, they have to share the same base. It's like terms in polynomials. You can't compress logs of different bases. Okay, so I have log in base 4 of x plus log in base 4 of y. My simplified form would be log in base form of xy, just x times y, right? Okay, let's take a look at this one. Log in base 2 of x squared minus log in base 2 of y. Okay. What would this one look like? Okay. Log in base 2 of x squared over y? Okay, we'll leave it like that now. What about the next one? Now be careful. I have 2 log in base 3 of x plus 4 log in base 3 of y minus log in base 3 of z. They're all the same bases, right? Yeah. You see something else going on here, though? I've got coefficients, right? So if I'm putting things in expand, coefficients expand things further. I want to shrink this, right? So what would I do with those coefficients to shrink everything down so that I could combine my logs? They become the exponents, right? So first, this would be log in base 3 of x squared plus log in base 3 of y to the power 4 minus log in base 3 of z. Okay. Now I'm ready to shrink everything, and when we simplify, simplified form only has one log statement, right? Everything has to be squished together to the same argument. So I'm going to have only one log in base 3. So what happens with the x squared, the y to the 4, and the z? These two get multiplied, right? And then my z gets divided. Agreed? What about these? Do these lawns have the same base? What base is it? E, right? That 2.7 E? Okay, so can I combine these two? What do I have to do first? Yeah, move the 2 over, right? I've got this coefficient 2. So this will become ln of x minus 4 subtract ln of x plus 5 squared, right? Now combine to one ln, which is log base e, right? X minus 4 all over x plus 5 squared. So to simplify logs, we compress them into one argument, and how we do that is through multiplication or division, and sometimes moving the coefficient up as an exponent if there's a coefficient. And then working the other way, we can use the laws of logarithms to expand each expression, so to expand it into individual logs, all right? So let's look at this. I have log in base 5 of x cubed times y. How many log statements will you have in the final answer? 2, there should be 2, okay? So take a second, expand those. Okay. So, first thing, did you log in base 5 of x cubed plus log in base 5 of y? Okay, one last step. What's the last thing we can do to expand as much as we can? Yeah, drop the 3 down as a coefficient. Great. Okay, try the next 3. Right. Okay, try the next 2. They look a little more complicated because they have radicals. Okay? Radical signs have no place, unless you're finding a value at the end, like trying to find the value in a word problem, but they don't really have any place in the laws of exponents or the laws of logs, do they? Radical signs don't appear in the laws of exponents or laws of logs. So I would suggest getting rid of those radical signs. And then you can use your laws of logs or exponents. So these guys involve radicals, right? So I kind of gave you a big hint. Radicals don't appear anywhere in the laws of or exponents or logs, so you have to have just exponents, right? So every radical can be rewritten as an exponent, a fractional exponent, right? So this would be like ab to the 4 all to the power of a half, right? Not 2, 1/2. Okay, so that gives us an exponent. So then what we would do is, it's 1/2 ln A, right? Plus 1/2 ln B to the 4. Okay?
Would you drop down 4?
Now, I guess I could simplify in this stage, right? I could write it like this, ln A to the half.
No. B, yeah, 2.
Actually, I don't think I would do that here. Let's try this. Let's just simplify over here. So we could say 1/2 ln A plus ln B squared. Yeah, you could just do that, right? To simplify as much as you could. Yeah? Because that's also an exponent, right?
Can we bring down the 2?
Further, you mean? Go further. Yeah. Like that. Good. Okay, what about this guy? It's a cube root. So it's going to be log 6 initially, 36x to the power of a third, right? Cube root is power 3, all over y squared. Okay, so now what do we have? We have cube root, or 1/3, sorry, log base 6 of 36 plus
36x.
1/3 log 6x, because these guys can be broken apart, right? It's 36 times x, it's like a times b.
Okay.
Yeah, minus log, yeah, I guess if I'm going to do everything in one step, minus 2 log y, base 6. Sorry.
Can you change that log 636 to
Yeah, you could actually simplify further, okay? If you were simplifying as much as you could, because what is log in base 6 of 36? Just 2, right? So this would be 1/3 times 2 plus 1/3 log base 6x minus 2 log 6y, right? Which would become just 2/3. How many people besides Eileen caught that? That's pretty advanced. I wouldn't expect everyone to get that at this stage. That's pretty advanced, right? So if you just got up to here, that's great. 1/3 log in base 6 of 36 plus 1/3 log in base 6 of x minus 2 log base 6 of y. Good? Everyone got that? Okay, good. All right, so this is how logs work. Very similar to how exponents work because they're inverses of each other. So it should make sense that they share those properties of multiplication and addition being attached to each other and subtraction and division. Okay, should we, I'm just wondering if I can get through. I'm going to try. Let's get through another page, then I'll let you guys go for a break. Okay, what about this? Use the laws of logs to evaluate. Now, this word evaluate, what does it mean? Come up with a numerical answer, right? Get a numerical answer. Oops, sorry. That word value means come up with a value, as Carlos said. Evaluate, it's really important to look at instructions and to know what your answer should look like, because it can guide you in your strategy. Now, how do these three questions, it says use laws of logs, we were just doing that. How do these three questions differ from what we had on the flip side? Like log in base 5 x cubed y. Why didn't I ask you to evaluate? I just said expand. Use the laws of logs to expand. What's the difference between this and this? Yeah, I gave you numbers here, right? Here you just had variables. You were just playing with the law. But if it says evaluate, that means I'm giving you solid numbers. So you should be able to come up with a solid numerical answer. Okay, so we've played with the laws. Now use them again, but in a real situation where you have real numbers to play with. So log in base 4 of 8 plus log in base 4 of 32. Can these two logs be combined?
Yes.
So it would be log in base 4 of, what, 8 times 32? Okay. And we'll use our calculators. We can use our calculators for this. So 8 times 32 is what? 256?
Yeah.
Okay. Now, kind of stuck here, right? Does anyone know what exponent I have to put on the 4? That's what I'm looking for, right? 4, if I'm asked to log something, I'm looking for the exponent to some exponent equals 256. What is the mystery number, do we know? I think it's 4, isn't it? 16 times 16 is 256, right? So x is 4. Okay, let's just step back for a sec. Would you have guessed that to evaluate these two logs, my answer would be 4? Probably not. Let's just see why we're studying logs again. What I did is I took my two logs and I took an expanded version and I converted it just to a simplified 1 log. Can you see why that's so powerful? Taking the 2, converting to 1. Once I have a term or an expression converted to just 1 log, that allows me to write it in exponential form, right? And then solve it quite easily. Make sense? So that's what these laws of logs do for you. They take something really long and complex, allow you to squish it into 1 log. As soon as you get into 1 log, as soon as we've simplified to 1 log, we can write it in exponential form. Oh. This way, we actually kind of used our same base technique, or just kind of memory work or visualization, because 4 to some power equals 256. Hopefully you remembered that the square root of 256 is 16, and you can kind of work backwards there, or you could do a full-on same base approach, right? 4 to the power x equals 4 to the power 4, so x must be 4. All right, this one is super easy now when I look at it, right? After all the work we've done, what's the answer? 2, right? 9 to the power 2 equals 81. Okay? All right, just to refresh and kind of set your mind of how far you've come even just since yesterday, right? When we look at a simple log. Okay, let's do this last evaluation and then I'm gonna let you guys go for a break. 2 log base 2 of 12 minus log base 2, 6 plus 1/3 log base 2, 27. The good thing is they're all base 2s, so we should be able to do a lot of compacting here and write as 1 log. I'm going to give you a minute to Thank you. Very complex, especially at the first, we haven't been doing this that long. Okay, let's see what we got, piece by piece. We've already established they're the same base, right? So we can combine things. I think the first thing I would do is just get rid of the coefficients, right? Express them as exponents, because I can't use my logs till my coefficients are gone. So the very first thing I would do is rewrite this as log in base 2 of 12 squared, right? Minus log in base 2 of 6 plus log in base 2 of 27 to the third, right?
It's 3, right?
Simplify.
Yeah, this is 3. I think I would simplify that to 3 as well. So then we can, these two, because they're both being subtracted, these two both go on the bottom, right? So then I get log in base 2. I'm ready to put them in one log. 144 is on top. And on the bottom, it's going to be 6 times 3. Yeah. Cube root of 27 is 3. Now, these two are multiplied together, right? Because of the plus sign? Because they're both subtracted, they go on the bottom. Okay, let's keep going. Then I have log in base 2 of 144 over 18, which is 8, isn't it? Yeah. So I get log in base 2 of 8, and now many of you were saying, okay, once I get to this stage, I actually know what the answer is, right?
Good afternoon, everyone. Sorry for the interruption. Students, just a reminder, for those of you who have already signed up and paid the $20 for the CPR first aid training, it is happening here tomorrow in the student lounge starting at 9 o'clock until 3:30. See you there.
So the answer is 3. That's the exponent I need. I saw a few people walking around that got it, so excellent. Okay, go take a break and I'll see. I might stop. lecturing now, but I'm gonna give you some homework. Go take a break, come back in a few minutes and I'll write out what you can do for homework.